Okay, now this is the 32nd question from the exercise of H.C. Verma topic kinematics. And now it is said here, a ball is thrown horizontally. So here the ball is thrown horizontally with a speed of 20 meter per second. So this point becomes the origin, and this question is on projectile motion. So the stone will fall like this, and we need to find first what is the time taken by stone to fall down. So the time taken by stone, as this is the origin and the building is 100 meter, this is y axis. So obviously the y coordinate is minus 100 meter. So we need to find the time when the y coordinate becomes minus 100 meter. And as the ball is thrown horizontally, so initial velocity in y direction is 0. This is the velocity in x direction. So how much time it will take? And we know that the acceleration in y direction is 9.8 meter per second square, and it is again in the downward direction, so I'll take negative. So now we have position, that is displacement. So I can apply y is equal to ut plus half at square. So we want y as minus 100. Initial direct velocity in y direction is 0. So it will be half into a, which is minus 9.8 into t square. Now on solving, you will see that this minus and minus get cancelled. This is 100. This becomes 4.9 into t square. So t comes out to be 100 upon 4.9 in root. So I can say this will be approximately equal to, because 4.9 can approximately written as 5 for easy calculation. So this comes out to be under root of 20. Okay, so it comes root 20 seconds. While the root of 20 will be 4 point something, because 4 ka square is 16 and 5 ka 25, and it is somewhere in between. So I will write approximately this as 4.5 second. While solving MCQs also you have to make such approximations. Okay, and you have to take the near answer. This is the A bit. The how much is the horizontal distance traveled? So we know that the horizontal distance traveled, I'll take the next page. So how much is the horizontal distance traveled? So as it takes time approximately 4.5 second, so the horizontal distance will be equal to speed into time, because in projectile motion horizontal motion is uniform. So 20 meter per second, that is in 1 second it travels 20 meter. So in 4.5 second how much it will travel? So our answer comes out to be 90 meter. Okay, because 45 2 is 90, 900 and point after 1. So this comes out to be 90 approximately. Okay, because time we have taken approximately. Now if you see the velocity with which it strikes the ground, so with what velocity it is going to strike the ground? So you will see that in this projectile motion, before reaching the ground, the velocity in x direction will not change, because x direction, the motion in x direction is always uniform. But due to gravity, the velocity in y direction is increasing. Okay, so this is the final velocity before touching the ground, and we need to find it. So final velocity before touching the ground can be found out by using v square is equal to u square plus 2a and displacement in y direction. So this comes out to be, this is 0, this is 2 into 9.8 negative, and the displacement is also minus 100. So velocity in y direction ka square comes out to be, so 2 into 9.8 is 19.6, and 19.6 multiplied by 100 will be 1960 meter per second. Okay, so velocity in y direction will be under root of 1960. Okay, now 1960, so that can be written as, for example, the root of 196 is 14 and root of 10 is 3.13 something. Now you can find it. So it comes out to be, after multiplication, 14 into 3.1. Okay, so you will get the answer in y direction. Finally, we need to find the direction of velocity, that is angle made which it will make. So this is the main velocity. So the velocity vector comes out to be 20 I cap and minus 14 into 3.13 j cap, whatever the answer will come. And how much is the angle made by this? So angle made by the vector is nothing but its y component upon x component. So it will be 14 into 13.13 upon 20. So it comes out to be tan inverse of this thing, whatever it will come. You may have to refer the log table for this angle. Okay, thank you.